Okay, so what we want to talk about today is we are doing hypothesis testing. Okay, so this is, let's see, I'm going to use my, okay. So hypothesis testing is different. It's another topic. This is actually, comparison, I would say, versus the confidence interval estimation we talked about last week. So there are two different topics, and so hypothesis testing versus confidence interval. Why do I say that? Okay, so let's see. So I've already posted a bunch of tables and also formula sheets on Canvas, and so let's see. So you guys have already probably seen this one. So there are different types of problems. So you can see for numerical data, and this is comparison to categorical data. So numerical data, you can be asked for this part is about sampling distribution of the sample mean. So that week I asked you guys to watch the rabbit video. Do you guys remember the central limit theorem, right? Rabbit. Okay. And then there's a confidence interval, which we talked about last week. And this week, what we are doing is hypothesis testing, right? Okay. So same goes for the categorical data as well. So for categorical data, we talk about a sampling distribution and confidence interval. That's what we did the last time. And this week, we're going to talk about hypothesis testing, right? You probably have already seen that. Okay, so if it's a categorical data, there's only one bubble here, right? You can see there's a big bubble here. For numerical data, on the other hand, there could be two bubbles, two different situations. So this one is when the population standard deviation is given. Okay, we talk about the Z multiplier. Hopefully you guys are able to see. So the Z multiplier here. And if sigma is not a given, the population standard deviation is not, we are going to use a T distribution, right? This is what we talk about to take a look at the second set of distribution we discussed for this class. That's a T distribution. Okay. And same goes for hypothesis testing. We're going to consider two different scenarios if population standard deviation is known versus it is not known. So this set of handouts is posted on Canvas, and you guys, make sure you print out a copy. Or if not, you can save it as a PDF. Okay, so what we are doing today is pretty much working on this summary table. So hypothesis testing summary table. So there are several different scenarios here. So this is a hypothesis testing problem. So you can see there's a lot of formulas, but they are somewhat repetitive, to be honest, very repetitive. And if you have difficulties of how to set up a non-alternative, which I'm going to show you several examples later on, there's more explanations here. Hopefully you have already watched the video and you have already taken a look at this. If not, you can do it after class as well. Okay, so I'm going to go back to the worksheets we were working on. And so I'm going to do a quick summary, and then we're going to start working on actual problems, right? Okay, so let's take a look. So the very first one we have. So first, as you can see, I break the problems into two different types. So there's a numerical problem that's going to be dealing with a mean problem. And the highlighted text says it could be a Z test, it could be a T test. Okay. When we are looking at a categorical data, it could be proportion problem. Over here is going to be only a Z test, right? Okay, so I'm going to write down several things that you guys can see how I'm going to just write out the formula, and then with some actual problem we can practice. Okay, so do you remember what is the step one when we are doing hypothesis testing? If you watch the video, there's only every time I solve a hypothesis testing, I strictly follow those 4-step problem. So 4-step solution. So there's 4 steps to it. What is the first step? What is the first step? Who wants to give it a try?
To create your null and alternative hypotheses.
Yes, create a null and alternative. Okay, create null. Well, this is awkward. Okay, so the first one is to write out a null and alternative. Okay, so let's try. Okay, I'm gonna write it out here. So this is a null. Oh, hold on a second. Well, so this is a null. H0 is a subscript 0. 0 means origin. So null is something that you try to compare with, right? Okay, H alternative. HA. Okay. So write out a null and alternative. There's a tip I always tell my students. The easiest way to write down the null and alternative is to start from the alternative. This is typically much easier to write. And the reason I say that is because alternative is typically your research question. So this is your research question, right? Research question. Okay, so what is the null then? The research question means something that you try to, something that you try to test, right? So what is the null then? Do you remember what is it called? If this is your new statement, for example, if research question means your new statement you try to test, right? So how about a null? What is the null called then? It's called status quo. I'm gonna write it on status quo. Do you remember somewhere in the handouts? Okay, so the null is gonna be the status quo, right? Okay, good. And so let's see. So you have to write on the non-alternative, and so if it's a mean problem, okay, the symbol you're gonna put down here is always a population mean. I'm gonna write down here is always a mu, and there's also a mu here, right? Okay, and as I was saying, typically it's much easier to write down the research question, the alternative. Okay, so you probably want to start from this part first. Okay, so just say that we are working on with an upper tail test. Okay, so let's see, I'm gonna write down here. Okay, you probably have already heard of this statement already. So just say that we are working on with an upper tailed test. Upper tail test. Okay, so if it's an upper tail test, what do you think the sign of this inequality gonna be? What do you think? For the alternative, is it gonna be mu? Is it gonna be less than or more than or not equal to, or maybe equal to? What do you think for upper tail test? Who wants to give it a try? Upper tailed. Okay, I'm gonna.
Yeah, would it be the equal to or greater than 1?
If it's gonna be greater than. Okay, good. Okay, I want to stop there. So it's not greater than or equal to. This is not right. And the reason is because, okay, so this is very, very important. So this part is super important because the equality sign, okay, so the equality sign should always appear in the null statement. It should not appear here. Okay, so the equal sign should not appear in the alternative. The alternative does not have an equal sign. Very, very important. Okay, so the equal sign should be there. And just say you were comparing with a number. Just say you were comparing with 5. Just say it's going to be 5. If it's 5 here, you're going to put a 5 here as well. Right? Okay. And if you watch the video, you probably know, okay, so the 5 here, okay, so the 5, okay, I'm just going to use a different color. So the 5 here, it represents the mu 0. Right? Why is it called mu 0? Because if you look carefully, what is the value? What is the value of a mu in the null statement, in the mu in the 0 here? It is 5, right? You guys see it? It's equal to 5, so that's why mu 0 is 5. Mu 0 is 5. Okay. So another thing I want to change here is because null and alternative, they are completely opposite. If we know the alternative is greater than, then the null H0 should be less than, right? Should be less than. Okay, so I'm going to change it to less than. Okay, is this part clear how I set it up? Okay, I'm going to test you guys again. Okay, so what if I was working on a lower tailed test? If it's a lower tail test, okay, so what do you think the null and alternative is going to be?
Would it be the opposite? So the null would be greater than or equal to 5, and the
yes,
yeah,
absolutely right. Sarah, you're right. Okay, so let's see. So mu 0 again, it is 5, right? Again, it is 5, right? Is that part clear how I saw it? Okay, great. And so this part is easy. Okay, and how about we also talk about two-tailed test. Two-tailed test. So two-tailed again, it is going to be mu H0 H0. Okay, so you want to set it up as equal to 5, not equal to 5, right? Okay, 5 versus not equal to 5. Okay, so there are only 3 different types of tests: lower tail, upper tail, and two-tailed. And how we set it up, we take a look at our alternative statement. We always want to start from the alternative, right? We always want to start from the alternative. Okay, great. So step 2, okay, so step 2. Do you remember what is a step 2 called? So what do you do in step 2? You set up the null and alternative. What do you do next?
You find the test statistic.
Yes, test statistic. So what is a test statistic? Okay, so how do we remember? What is a test statistic? Test statistic is just some kind of evidence from your data. Test statistic is something from your data. This is evidence from your data. So you want to take a look at the evidence you have from the data. Okay, so test statistic could be a z-score. It could also be a t-score, right? It could be a z-score, it could be a t-score. Okay, the reason I say that is because it really depends on whether the population standard deviation is given or not. Okay, so I'm gonna write it out here. Okay. So if sigma is given, so you probably remember, what is a sigma? What is a sigma? It's population standard deviation, right? It measures how wide or how narrow the distribution of your population. If it's not given, if sigma is not given, okay, this is gonna be a t-score. I'm gonna write down the formula. You guys have already seen it before. So if it's a z-score, that means sigma is given. It's gonna be called, the formula for that is gonna be x bar, the sample evidence from your data. Your data is gonna be your sample. X bar is the evidence from your data, the average of your data. Subtract mu 0. So mu 0, that means, okay, hold on a second. I want to compare my evidence with the 5 we set up here, right? I want to see how far this is away from those 5. If it's much further away from it, that means we have a lot of evidence against the null, right? Okay, and we are not done yet. And the reason is because we want to standardize it using sigma over square root n, right? Okay. Similarly, if sigma is given, that's going to be a t-score. It's going to be x bar minus mu 0. Okay. Because sigma is not given, this is not a known, so we can't use sigma anymore. Sigma is not there. We have to use the sample standard deviation. Sample standard deviation, which is S over, okay. Right. Okay, so there's only a subtle difference between those two. Okay, just the formula is somewhat slightly different, but when you look up the table, it's going to be different as well. Either going to be a z table versus a t table, right? Okay, good. So you can plug in the numbers and get a bunch of numbers. And so what do you do for step 3 then? What do you do in step 3? So you establish this evidence. This is pretty much your score, right? If your z-score just is 0, if say, you do the calculation, you found out your z-score is 0, that means your sample average is not a very different from 5, right? It's not a very different from 5. So you probably have a lot of evidence to support your null. If it's very far away from the null, if it's very different from 5, that means your z-score is going to be huge, and then you have a lot of evidence against the null, right? So that's the ultimate spirit of doing the hypothesis testing. You just compare your evidence with the mu 0 value you established. It could be 5 or some other value, whatever value you try to compare with. Okay, so after you do that, you arrive to step 3. So what do you do in step 3? You have the z-score or maybe a t-score. What do you do with it? We talk about 2 different approaches in the slides. Remember, 2 different approaches.
Is it where you find the significance of it?
So you're gonna make use of the significance level to find a critical value, right? So there are 2 different approaches. I'm gonna write it down here. So for almost all of the examples in the slides, I solved the problem using 2 different approaches. So the first approach is called critical value approach. So critical value approach means you just try to compare whatever you have here. You're going to compare your z-score with another threshold you establish. This threshold is a cutoff value. Is going to be also called a critical value here. The second approach is going to be a p-value approach, right? Okay, so critical value approach, how do you find it? Okay, I don't know whether you were able to see the pattern of it. So whenever you find a critical value approach, what you do is, Sarah was right, you start with a significance level. Okay, so you start from the significance level. This is typically given to you, and this is known as alpha. So alpha typically is going to be a small value. It could be 5%. It could be 1%. Some other time it could be 10%. So that's going to be those three commonly used three significance level. From that, you're going to use your table to find your critical value, to find the critical value, right? Okay, so this is how you typically do that. And so after you find your critical value, you can move on to step 4. Step 4, I know I haven't completed the p-value approach yet, but I just want to quickly conclude this part. So once you figure out the critical value, what you're gonna do is you want to compare your z-score, or maybe, yes, hold on a second, I'm gonna change this one. You wanna compare your test statistic. That means this is the evidence from your data. Compare critical value, test statistic with the critical value, right? CV is the critical value. Okay, and then you're probably gonna reject the null. Okay, so if you watch the video, you know, every time I make a conclusion, it's always about a null. It's always about a H0. I don't say much thing about alternative. I just say whether I rejected a null or I fail to reject a null. I don't say things like I reject the alternative, or maybe I accept the alternative. No, it's the statement you make about hypothesis testing from hypothesis testing is always about a null. Whether you reject it or maybe you fail to reject it. Some other people is gonna say accept, but I try not to use that word. You can think in your head this is accept, but in reality you want to say not enough evidence to reject it. You know, it's sort of like accept, but there's a subtle difference to those two. So not enough evidence to reject it. Okay, so you can reject it now, okay, or fail to reject the null, right? Okay, and I'm just gonna erase this part because I need a little bit space here. Great, okay. And so let's go back to the p-value approach. So how do you find the p-value approach? So p-value approach is different. Okay, so p-value approach is different from what we did here. So for critical value approach, I start from the alpha. I don't find a critical value. For p-value approach, you don't do that. P-value approach, you start from your test statistic. You start from your test statistic, and then you use the table. So use the table to find the p-value. Okay, so since we talk about p-value, I'm gonna ask you several other things. So what exactly is a p-value? So what is a p-value? Okay, I'm gonna give you two options. So the first one is the p-value is very much like a score, like a, you know, it could be plus minus 3, plus minus 2.5, or maybe minus 1.7. So it's very much like a test statistic or z-score or t-score. The second option you have is p-value is a probability. If it's a probability, that means it's going to be between 0% to 100%. What do you think? You have two options. Yes, two options. So is it going to be a test statistic or is it going to be a probability? Are you guys thinking?
Probability.
Probability, right? Probability. Okay, very, I'm going to write it down here. Okay, so 0. Right? If it's a probability, that means it has to be between 0 and 1. So some other time, if you do the calculation, you find out your p-value is 1.6. You should be alert, and you're like, okay, it can't possibly be the right answer because p-value is a probability. It has to be less than 100%, right? So this is very, very important. Great. Okay, so let's go back. And so after you find a p-value, okay, So what you can do is you can make a conclusion. I'm talking about step 4 here, step 4. Okay, so what you're gonna do is you want to compare your p-value with alpha, Oh, terrible. Okay, so I know there's like a lot of things I want to emphasize here because they are all super important. Okay, so p-value, whenever you have a p-value, okay, regardless what kind of a test you're working on, what I meant is regardless whether you are dealing with numerical data. Okay, so what we are doing here is numerical, hold on a second. We are dealing with a numerical data here. You could be also working on categorical data later on. You could be dealing with, say, upper tail test, or maybe a lower tail test, which I have already erased, or maybe a two-tail test, regardless what kind of a test you have. Okay, so this is always true. That's why I'm going to change my color to red. Okay, so you are always going to reject the null if p-value is small. Okay, so how small is going to, is going to be called small. As long as the p-value is less than or equal to alpha, you are always going to reject the null. Okay, because p-value actually measures, p-value is a probability. It just tells us what is the likelihood of observing your data if the null is true. Okay, if p-value is super small, that means it is very unlikely to observe your data if the null is true. So that implies the null is not true. And that's why you should reject it, right? That's why you should reject it. It's very unlikely to know, to have this data if the null is true. That means given we observe the data, that means the null is not true. So there is some kind of a relationship going on, intuition. Hopefully you guys, agree with me. If not, send me an email. I can explain again, using more words. Okay, so this pretty much summarize first numerical data part. Okay, and you guys can set up the same one for the proportional data as well. I'm just gonna quickly write it out. It wouldn't take a lot of time. So it's gonna be a null and alternative. Instead of a mu, you're gonna have a p here. Okay, I'm just gonna write it out for two-tailed test. This is gonna be an example for two-tailed test. Okay, if it's a two-tailed test, it's gonna be a p0 not equal to p0. So hopefully you guys are able to see this is a two-tailed test, right? Okay, and for step 2, it's gonna be our test statistic. As you have already seen here, it's always going to be a z-test. Just like what we did for confidence interval, you can never get you don't use a t-distribution if it's a proportional data. And so that means this is always a z-score. And the formula is p bar, the sample proportion. You compare it with the p0 here. P0 is right here. So that's going to be p0. And the formula is p0, 1 minus p0. Hopefully you guys agree with me that the denominator is something that you have already seen last week, right? You remember it? This is how we got the standard error, right? You remember the margin of error, then you multiply by a z multiplier in front of it, right? Okay, this is similar, but not identical. This is very, very important. Okay, I know. Okay, so the formula you guys did last week. Okay, so MOE from last week, from module 3, it is a z multiplied by p bar 1 minus p bar square root n. So you can see they are similar, but not the same. I've already taught this class. This is my 6th year teaching this class. I know for sure some of the students are going to use a p bar here instead of a p0 because they remember it from here. They are not the same, right? And why can't you use a p0? The reason is because you are testing your proportion, your population proportion with a quantity that you are comparing with a p0, say 50% or maybe 1/3. You are comparing with 1/3, so you want to change it to 1/3, not a p bar, right? Okay, so this is different. Okay, and I will just continue here. So for step 3, you are also going to have a critical value approach. Oh. So you could also have a critical value approach. You could also have a p-value approach, right? Everything is pretty much the same as what we talk about here, very much the same. Okay, except instead of using, you know, I think everything is the same because you're going to use a z score here, so it's going to be the same. The conclusions are going to be the same as well. Any questions there so far? Any questions here? And we can, you know, work on a problem, so later on it will be easier for you guys to see how I solve the problem. Always have a systematic way of doing that, and hopefully, hopefully you guys can, you know, hopefully that systematic way is going to help you guys too, right? Okay, okay, great. And so, you know, I also type it out here. Okay, just say a p-value is equal to alpha. You are also going to reject it, right? You are also going to reject it. Okay.